Hello, this is another episode of Exploring Rust. This time I'm going to look at the Minigrep program in the Rust documentation that gives you as an example of how to, structure Rust programs and how to bring together some of the things that you've learned if you've worked through the documentation to that point. It took me really a long time to work through these. I think it's 6 pages. There's a lot of verbiage in there which I don't do well with. If I've got to read stuff that I'm not really that fascinated by, my concentration span is extremely small. It's a different story when I'm really interested in it, but this just didn't grip me. And I don't think at any point it actually presents you with the entire complete program, which I found frustrating. I don't want to knock whoever created the documentation. It's extremely useful. It's a great resource. It just doesn't suit my way of learning stuff. Anyway, I have managed to work through the entire thing. And what I want to do here is, I'm not going to do exactly what the documentation does. I'm not going to go through step-by-step different iterations of the program in exactly the way that it does, because I don't even remember that. It will do one thing and then progress to another way of doing it and so on. But what I will try to do is write the complete program here, explaining it as I go along as much as I understand it. And I'll do it step by step, which is, the way that I normally write programs is I would write a bit and then test it somehow. So I'm going to do that. So first of all, we need a package for this. Let's do cargo new minigrep. And then we'll go into there. And I always like to just check that it runs, although it always does. There we go. Hello world. So this will have created a kind of binary package. So in the source folder, there's going to be main.rs. I'm also going to create lib.rs, which is the other file that the Rust compiler will actually look for by default. So I'll just use touch because I'm on a Mac. Let's do touch source / lib.rs. So now we can start the actual programming. Let's go to main.rs. I'll get rid of this sidebar and I'll see if I can make this a little bit bigger to start off with at least. So a lot of the pages in the documentation, I would say like half of them, are really devoted to just processing command line arguments. Let's go ahead and do that. The final program actually is like a version of grep with stripped down functionality. It just lets you search for text in files. So I'm going to use standard env like this. And then we want to get the command line arguments. So let's get rid of this and replace it with let args. And that's going to be a vector of strings. So vector of string, that's the mutable string type, equals, and we can use env : args. So this is a function in the env package. And this returns, I think, something that's iterable. I'm not getting any documentation here when I hover over it. But what we want to do is collect this together in a vector, and we can do that using the collect function of whatever that is. So this should give me a bunch of arguments. And I think there's a debug macro that I noticed the documentation uses, which I think looks like this. So let's see if I can just use that to print out the arguments that we've got, command line arguments. So now I go to the console here. And if I do just cargo run, what have we got? Did I save this? No, I didn't. Let's save it. Okay, let's try again. Yeah, so I don't know if that's maybe almost off the edge of the screen. Let's just adjust this a little bit. Try that once more. So you see that the first command line arg that is automatically supplied is the name of the program, which is, I don't know if that's a Rust feature or just a sort of terminal feature, but that's pretty typical. However, we can supply our own command line arguments. Let's do something like, and we need hyphen here to say that we want to supply arguments not to cargo, but to the program that it's actually running. I can't remember which way round these arguments go, but let's put some text like hello and a file name that it would in theory search, like temp.txt. And if I run that, we can see that we've got those coming out in the command line arguments there, so they're now in a vector. Now I want to go to lib.rs and we're going to write some stuff in there. If we put it in lib.rs, that's going to create a library our program can use and other programs could potentially use it. And importantly, we can also write tests for it. So now I'm going to have a struct which has to be pub so we can access it from outside the, I I guess, the library package, or just the library. The library's in the Minigrep package, I think. So yeah, we just want to access it from outside the library. Still not 100% sure how this all works, but I'm going to call this config. And that's going to collect command line arguments. So we need some public fields because we want to access those outside the library as well. I'm going to have query. That's the thing that the user searches for. And all of this is directly from the Rust documentation. I haven't made this up myself. We'll also have a file path, which should also be of type string. And it doesn't introduce this until later on, but let's put it in now. Let's have a pub ignore case of type bool, which is going to be set ultimately via an environment variable to say whether you want to do a grep on your text ignoring case or not. And then we want some implementation for this config. Let's say impl config, and in there I want a public function which will be called build, and that's actually just going to accept the vector of arguments. So to specify the type here, this surprised me a little bit. Okay, we have a reference, which is not very surprising. We don't want to clone the vector and pass it around. We just want to pass a reference to it. That makes sense. But then instead of writing vec here, we have just square brackets, which I suppose must be some kind of alias for vector or something. Anyway, in there we put string to say that it's a vector of strings. And then what we're going to return is going to be a result, because we want to be able to say if there's some kind of problem with processing the arguments, like if there's not enough of them or something. And that's going to return a config if things go okay. Otherwise, it's going to return a reference to one of those like immutable static strings. So let's put the curly brackets in. So to start with, we can say that if the number of args, so if args.len, that's the length of the vector we're passing in, is less than 3, then in that case we're going to return error. And I'm going to have a message there. Let's put here not enough arguments. Otherwise, we can go ahead and put the parameters into that config struct. So we'll say let query be, well, that's of type string, and that's going to equal args1, not args0, because that's just the name of the program. And rather than use a reference here, I don't know if we could use a reference or not, but it's pretty simple to do clone. And the documentation says that Rust programmers use clone a lot, because although it's not exactly efficient because you are copying the whole string, in a situation like this it's really not going to make any difference to the running or efficiency of your program just to clone a couple of strings. And we'll also have let file path. I'm giving these variables deliberately the same name as the fields, that should be pub up there, in my struct. So that's also of type string, and that's going to equal args2, which will also clone. What about ignore case? Let's just deal with this here. The documentation doesn't deal with this until like the last couple of pages or something, but it's not that complicated. I want to say let ignore case of type bool equal, and I'm going to use an environment variable here. So to do that, I can just say at the top, let's go to the top, use standard env, and then that will allow me to use functions from the env package. And I can use the var function, and we just want to supply to that ignore case. Well, that's lowercase, that. I want it uppercase. Oh yeah, but it should be a string though. So ignore case like that. That's going to be an environment variable. And I'm just going to use is okay. So I think this is just saying set bool to true if this actually exists. If it doesn't exist, then ignore case will be false. Maybe make this a little bit smaller. So now we've got all that, we can return a new config struct. So I use the OK field of result, which is what we're returning, and I pass in there, so I don't put a semicolon here because this is a return value, and I pass in a new config. We have curly brackets there, and then I can just put in the fields. That's a shortcut way of setting the fields in the struct, which we covered earlier on. So we've got query, file path, and ignore case. So that's probably all okay now. So now, if I run this and I pass my arguments to it, we should be able to see what? Well, we should get this OK value containing a struct, which I think we should be able to then print out. So let's try to do that. So I go back to main.rs and I'll get rid of that. And let's import this. So because it's in a library, we need to import via the package name, which is Minigrep. That's what I set with cargo new. So Minigrep config, I suppose. And then we can say let config, which is of type config, equal config : build. Because this function that I've created here, it doesn't have a self argument. So I forget the term for it, but it's kind of like a static function that we call via this syntax rather than a dot. And then I can pass a reference to this args vector to that. And then we've got to do something here, because what if we get error instead of the values that we hope for? So let's do unwrap or else, which we've seen before. And so that's a function. And then we use this closure syntax. I think I finally understand what a closure is after like 25 years of programming or something. It's literally just a piece of code that has its own environment. So it has access to certain variables, global variables, local variables, and so on. So this is some kind of closure, and we are going to get past the error there, and this is only going to be called if something goes wrong. And we have a pair of braces there, and then to print an error, I'm going to use ePrintLine. The difference with this and printline is that printline prints to standard out, ePrintLine prints to standard error, which would mean that, for example, you could use a kind of redirection character to send the output of the program to a file, that is the output that's sent to standard out, and you would still see the error messages separately appearing on the console. So here, let's say problem parsing args, and we're going to output whatever we get from error there, which is just going to be a string, because that's what we are returning right here. That's just a string. And then, so if things go wrong at this stage, we want to quit. So to do that, I can actually say up here, use standard : process, and we could say here process : exit, and pass in an exit code like 1, for example, and that's just going to quit the program. So I think this ought to work. Let's try this. So I'm going to do cargo run. First, try it without any arguments. Unused variable config. Yeah, I've got warnings here, but that's not surprising. And the actual output from the program is problem parsing args, not enough arguments. So now let's try this again with 2 arguments. And if I run that, yeah, it's run. We've just got warnings, which is fine. Unused variable warnings. So maybe I could try doing debug ! I think that has to have a string, maybe, or does it? I've forgotten. Let's put config in there and see if it prints that, and semicolon. So if I run this again, clearly it doesn't like that. Let's put a string in for the first argument here, and a pair of braces, and see if we can print that. So I think this ought to work. Let's try that. Config cannot be formatted using that thing because it doesn't implement debug. Okay, all right, I guess I can't do it then. Well, what I could do is I could put in some more braces and do config.filepath, config.query, and config. What was the other one? Totally forgotten what I called it. Ignore case, that's it. All right, let's try that then. Yeah, so no. Oh yeah, no, it has worked. So I've got, config file path is temp.txt, config query is hello, and ignore case is false. Yeah, so that's all correct. And let's create an actual file that we can use to demonstrate this. So I'm going to right click and go to, where do we want this? Not in source, I think, just in the root folder, which is the working directory of the program. So if I go to new file and we call this temp.txt, I can put some stuff in here. Let's write some stuff. I don't know, it was the best of times, it was the worst of times. I think that's going to be enough. Save that. So I just want to remind myself how I would actually use grep on the Mac. I've used it like a million times, but I can never seem to remember whether the file name comes first or after the search query. So on Windows you won't have this, but I'm just going to do grep worst and temp.txt. Maybe I don't have it here either. Where am I? Where have I just put that file? Yeah, probably I put it here. No, it's not there. Where is it? Okay, there's something weird going on here. I don't know where I am. Okay, I'm there, and if I look in the thing above, yeah, there it is. So where am I supposed to be running this program? What's actually happened here? If I created like some kind of weird nested folder structure, yeah, I think I created a Minigrep folder inside a folder called Minigrep. Okay, 1 second, I'm just going to sort out this folder structure here. I created this project earlier and ran through it, and I think I've got a folder left over from here that I didn't want. Okay, I've straightened everything out now. So now I've got a directory that I always create for the particular project, and within there's a folder called Minigrep, which was created by Cargo New. And so within this folder, I've got my source subfolder, the cargo.toml, and I've also got temp.txt now, so I've moved everything into the right place. So what I wanted to do was to say grep worst temp.txt. Yeah, so with the normal kind of grep that you get on Unix or Mac, or not Unix these days maybe, but Linux, you put the query string first. So that's what I'm going to try to implement. And then it just tells you which lines contain the text that you search for. All right, so let's go back to main maybe. I've got to close these files that are in completely a different place now. So now I think in lib.rs, the best thing to do next is to create a function called run, which is just going to run the whole thing, and it saves us putting a lot of stuff in the main function. So I'm going to have pub function run, and that's going to accept the config that I've now created, or that I can create using this build function of that struct. And it's going to return a result again. And we don't need to return anything in the case that we've just got OK. The output's just going to be written to the console anyway. So I'm just going to put unit for the return value nested in the OK field if things go all right. If things don't go all right, now this is the one bit that I could have done with the documentation actually explaining, but it doesn't actually explain it, or not in any detail. So instead of just returning an error here, we want to return box. That's a generic type. And here we've got some kind of keyword dyn, and we put error there. So we'd normally expect just error there, but we've got box dyn error, which keeps cropping up in this Rust documentation. And for what I understand, it's something to do with just wanting to be able to return anything that implements the error trait rather than specifically some kind of error. And the documentation does promise that we'll go through this later on. So I'm just going to have to, this is just going to have to be a matter of faith. Let's put the braces in there. And now we're going to output some kind of error message. Let's say print line, exclamation mark. And then here we'll have some useful text like searching for something in something. And then let's put the config.query, and let's get rid of this sidebar here, config.file path. Now how can I make this compile? What's the minimum stuff I need to put in? I think I could just return OK down here. Let's put OK. That's going to be the return value. So now I should be able to run that from main, right? So if I go to main, let's open that. Here's main. And I should be able to say minigrep run and pass in the config there. I get confused about when I need a reference and when I don't need a reference. I would have thought this struct should be best passed by reference, but I don't think there's a reference symbol in the documentation at this point. So well, I'm just going to go with this. And let's try to run it and see what happens. So cargo, where are we? There we go. Cargo run with those arguments. Yeah, it says not found in this scope. We've got to import that error trait back in lib. So we're using, where is it? We're using this. That's some kind of trait. And I need to import that from I think it's use standard error, : error. All right, let's try that. So it doesn't like OK. What's wrong with OK? No, I didn't put a, I don't think I put unit in there. That's got to accept some kind of object. Let's put unit there. And then we'll try this again. Yeah, so now it runs and it says searching for hello in temp.txt. We've also got an unused result warning because Minigrep returns a result which we're not making any use of, I suppose. So let's already handle that because that's pretty straightforward. So back in main.rs, I can use if let. So in the case of OK, we don't need to do anything. It's totally fine. But if that throws an error, we want to handle that. So I'm going to say if let, and then the thing that we want to match would be error or error equals the return value of this. And it's going to be an error that contains, I think I can just put E there. So this is actually a box-dine error thing, but I think it will infer the type of E if I put it there. And then here we have braces. That's got to be like that. And then I can say ePrint line exclamation mark. And we can just say here, if it returns an error, we can say error colon, and I think I can just put E in brackets there. And then we'll do again process colon exit 1, like that. So I assume by default this main is going to exit with a return code of 0. So it's only going to have a return code of 1, which like in C represents some kind of error in the event that something goes wrong. Okay, so let's see if we get fewer warnings now. Yeah, no warnings at all, so that's good. So now I can go ahead and implement this run function in lib.rs. So we need to load the text from the file that we want to search through. So I'm going to say let contents, and that's actually type string, we'll just let it infer the type, equals, and we can use fs read to string. So I've got to import that. That's going to be what? Use standard maybe fs. Let me check my notes. Yeah, it's standard fs, that's all. So we import this fs standing presumably for file system. Now I can use the fs read to string function and I can pass in config.filepath, which is the name of the file we want to read. Now I need some kind of search function. So I'm going to say let result equals search, which I haven't implemented yet. We're going to pass in a reference to config.query, and we'll also have a reference to contents, the file contents that we want to search through. Then I can implement search. So let's have pub function search, and this is going to accept a query, which is of type string, one of those immutable strings, and contents, which is also of type string. And that's going to return. Now, because it has to return different lines from the file, we're going to need a vector. Let's have a vector of immutable strings. And then we put the brackets in there. So I can create a vector here. Let's say this has to be mutable because we want to add things to it. I'll call it results. And that's going to be of type vector of immutable strings equals vec : new. And at the end, we're just going to return this. Now this actually won't compile, but this is just a lifetime type problem. Let's just try it and see what error message we get. So it actually tells us exactly how to fix it, except in this case the suggestion is wrong. It's not quite what we want. So if I implemented this, well, it might work, but it's saying, I think it really would, but it's saying that the lifetime of the return type, the actual strings in the vector that we're returning, would be the inferred lifetime, which will be the shortest of whichever this or this query or contents lives the least long. But as a matter of fact, this is just going to contain lines from our contents, from our file contents. So its lifetime really only needs to depend on that. So let's add that. So here after the name of the function, I say that we've got actually a template type function involving a lifetime of A, and we specify A here to say that this has a lifetime of A, and this will also have the same lifetime of A. The return value will have that same lifetime as the file contents. And now it should actually compile. Yeah, I've got a warning about unused variable, unused mutable, but there is a error here, I think. Where's the actual error? Missed match types, expected str found result string error. What? This is in lib.rs where I call search. Okay, I've obviously done something stupid there. Let's take a look. What did I do? Yeah, I see what's happened here. So here I've got to handle the fact that read to string can return an error. I'm forced to deal with that somehow. So let's go ahead and deal with that. And actually I've missed only a single character out of this. If I just put a question mark here, the documentation does go through different ways of handling this. I guess we could use if, let, or a match or something. But if I put a question mark here, if you recall from earlier videos, if you've seen those, in the event of an error, this is going to return immediately. It's going to make this run function return. That question mark will make the run function return with the error from read to string, which I suppose is why we need this box-dyn thing to convert different kinds of errors or something. I don't really know. And in the event that this returns OK, the question mark will give us whatever the OK field of the result that this returns actually wraps, and that should make it compile. So just a very small change just fixes the whole thing. Let's try that again. Yeah, so now it runs with a bunch of warnings but no errors. So now in search, I think I can actually implement this. All I need to do is say for line in contents.lines. So .lines being a kind of function associated with string here, with str. And in there I can say if line.contains, another string function, query, the thing that we enter that we want to search for, then in that case we'll do results.push line. And that should basically be it, I think. So obviously I need to actually do something with this. So where we call search, let's say let result equal, and then I'm going to say for line in result, because this is an actual vector that we can iterate over, print ln exclamation mark, and we can just print the line really. So let's just output that. So I think that should be a semi-complete program. We just haven't handled the ignoring case thing yet. Let's try it. So if I run this, yeah, searching for hello, there's no hello in there. Let's put it. Yeah, and then we've got our results. We've got 2 lines of results here. So if I try to specify a file that doesn't exist, we get a nice error. No, well, it's not that nice, but no such file or directory. It doesn't say which file, but we've already got searching for it in temp.txt right there. Actually, it would be probably nicer if I put some single quotes around this stuff, I think. So let's try that. Searching for it in temp.txt1. No such file or directory. And if we do it correctly, there we go, we get that. And if we search for something that doesn't exist, well, it just says searching, but we don't get any results back. We could output a message like not found, text not found in this file or something. And the other possibility is we don't supply enough arguments. So in that case, it's going to say problem passing args, not enough arguments. So that looks pretty good. And the only remaining thing to do is to implement the sort of case insensitive search feature. So to do that, I need another search function here. It's going to look pretty much like this one. Let's copy that, paste in a copy of it, and I'll call it search case insensitive. And when we ask if this line contains this query, I can do line.toLowerCase, and I need a lowercase version of the query as well. Let's create this up here. So let query equal query.toLowerCase, and then we've got our case insensitive grep. I think that looks okay. So we just need to call this function depending on an environment variable. So we're calling it here, and I'm going to change this a little bit. Let's say let result equal if config.ignore case. We have some curly brackets here, and we do something in that case. Else we are going to do the normal search. And what we do if we've got ignore case switched on, let's duplicate that and move this up here, and that's going to be search case insensitive. And now I think we've got the entire program that's in the documentation finally. So we're just setting result equal to the return value of the if expression, and that means we don't want semicolons here actually, because these are going to be kind of like a return value of the if. They're going to be what the expression evaluates to. So let's try this out. It should do what it previously did perfectly well. Oh, I missed some stuff off here. Expected semicolon found keyword for lib.rs line 35. So if I check that, what did I do? Yeah, that's got to have a semicolon at the end of the if. So try that. I should also, I think when I supply query, where is it? Line 63, that should be a reference. Yeah, okay. It's not a reference here. Well, it is a reference actually, because I passed a reference to this search function. But down here, it wants a reference, but this is now not a reference. So I have to pass in a reference to this local variable here. All right, let's try that. Yeah, so it's fine. On the other hand, if I change this so it has the wrong case, let's try was instead actually. That works just fine as well. Or we could try times. That's fine. But let's change the case of times. So I'll put a capital T, then it finds nothing. But if I set that environment variable, ignore case, it should then actually work. So how you set an environment variable, of course, depends on your shell. I'm using PowerShell here, which is a Microsoft thing, which would make many programmers suspicious of it, but it's actually pretty good, and it's cross-platform and free. So in PowerShell, to set an environment variable, I write $env : so I want to set ignore case, and I can't remember, is it an equals? It doesn't. I don't think it actually matters if we set it to anything, because just the fact that this environment variable exists will turn on the case insensitive version of searching in our program. Anyway, let's try that. Then if I run this again, now it finds times in there with a case insensitive search. And in PowerShell, I can do remove -item env : ignore case to remove that environment variable. And then in that case, once again, you have to have the right case when you do a search. Wow, so that was a lot of stuff. I think that the program, I think it's a pretty good exercise, really. It's okay. I mean, this is the sort of thing I'd normally do anyway to learn a programming language. I just didn't really get on with the fact that there's so much verbiage in the documentation. A lot of it is explaining stuff that after working through the documentation to that point is already fairly obvious. And I just have this problem that if I'm reading something I'm not very engaged with, my brain just tunes out. Actually, it's worse than that. I don't know if you can relate to it, but I start to feel really depressed. Like if I'm doing something I'm bored by, it really gets me down very rapidly. And I have to go back to doing something that I'm interested in. This has really altered the whole course of my life, and I'm not sure for the better or for the worse. But anyway, that's my problem, not really the problem of whoever wrote the documentation. And now that you've seen this, well, you don't really need this particular section of documentation, because I've just gone through more or less all of it. So that's it for this video. If there's anything you'd particularly like me to tackle in connection with Rust, do let me know. But what I am going to do right now is I'm just going to carry on going through the documentation. I can't remember what's next in it, but I think there's stuff coming up about multi-threading. Hopefully it's going to explain this Boxstein trait business. Yeah, there's quite a bit more that we've still got to cover.